I'm solving this problem. Once take a look on this problem. A uniform square of side 2L, a uniform square of side 2L. So this is one square. The side is 2L given in the problem. Is divided into four equal quadrants. Four equal quadrants divided into four equal quadrants like this. Now, if one of the quadrant is removed, for example, one quadrant, this is one quadrant which I mentioned with like this, and this can be removed from this square. Then what is the shift in the center of mass? We need to calculate. Actually, for this, without removing nothing, but before removing the part, one quadrant, what is the center of, where is the center of mass? Here the center of mass is present. O is the center of mass before removing the one quadrant of the square. Then after removing one quadrant of the square, where the center of mass can be shifts? That is the question. And this is the topic related to the shift in the center of mass. In the already you know that if you add some mass or if you remove some mass, the position of the center of mass can be altered, can be changed. So here we are taking the concept as removal of part. Removal of part. So for that purpose, here I am taking that at first in the case of shifting the center of mass, I used to say that if you don't know the mass, here we need to take mass is directly proportional to area. Mass is directly proportional to area. So mass initial I am taking nothing but before removing the one quadrant of the square, before removal of one quadrant of square, here I am taking the total mass, nothing but initial mass proportional to, this is the square plate, right? So what is the area of the square? Area of the square is nothing but side square. What's that? Side square. So now here, what is the side? 2L. 2L into 2L. 2L whole square. 2L whole square. And then with that, we are taking the concept it as M initial. M initial is directly proportional to 4L square. Just keep there. And this is the initial mass, nothing but before removal. After removal, so how much part of the square can be removed? That we need to know at first. How much part of the square is removed? Only this part. One quadrant of the part of the square is removed. So whatever the part of the square is removed, that part area we need to calculate. Removal part area we need to calculate. Try to understand. Removal part area. So removal part area is nothing but M removed. Here also that is proportional to A, area only. So if you want to calculate the area of the square, we need to know the side of the particular part. Now, here total we are taking the concept it as removed part. This is the removed part side. Total side, what is the total side here? 2L. In that exactly this is half. In the 2L we are taking half, nothing but L. I need to take the area of the removed part. Again, side into side, side square. L into L, L square. So M removed proportional to what? L square. M removed proportional to L square. So now here I know the initial mass, I know the removed mass. Initial mass means before removal of the particular part from that body, I need to calculate the total mass. That is the initial mass. Removed mass is nothing but how much part of the mass is removing from that particular body. I need to calculate mass of the removed part. How much mass is removing from that I need to calculate. That is M removed. So M initial is proportional to 4L square, M removed proportional to L square. Now here I need to calculate one more thing, that is small d, distance between the two center of masses. What about these two center of masses? Where are these? So now first center of mass is O. before removal of the mass. This is O. Another center of mass is the part which you removed. The part which you removed. For that, I need to take the center of mass. The center of mass of the removed part. The center of mass of the removed part. So the center of mass of the removed part is exactly at its center. That is O dash. O dash. This is the removed part now. So removed part center is this one. So O dash. O dash. I need to calculate. This O dash. The distance between the O dash is nothing but a small d. The distance between the O and O dash is small d. So d is equal to O dash. I need to calculate the O dash. For that purpose, here at first I need to consider. So this we consider along the diagonal. This we consider along the diagonal. So that's why here I need to calculate at first what is the diagonal of this square. Diagonal of the square. So here I am mentioning, try to understand, diagonal of square. Diagonal of square is nothing but what's the value? Root 2 into side. This is the formula. Diagonal of the square is nothing but what's the value? Root 2 into side. That is equal to root 2 into side is nothing but what's the value? 2l. 2l. Root 2 into 2l. But I don't want total diagonal. I want only, this is, see, observe carefully. Observe carefully. Up to here, half the diagonal. Up to O. Any one corner to O. That is half of the diagonal. Any one corner to O. Half of the diagonal. Okay. This I need to remove. I need to remove. Again, from here to O. Again, half of the diagonal. So it means half of the diagonal. In the half of the diagonal, we are taking again half. Observe carefully. From here to here, half the diagonal. From here to, for example, this I am naming it as A. From A to O, half the diagonal. In the half the diagonal, again I considered half only. Small d is nothing but what? From O to O dash. This is the half of the half diagonal. It means d is equal to O dash, and that is nothing but diagonal by half in the half of the diagonal. Diagonal by 4. Diagonal by 4. That is the value of small d. Half the diagonal means diagonal by 2. Again in that half by 2. Again diagonal by 4. That I required. So here I am mentioning that O dash is equal to, what is the diagonal of the square? 2 into root 2l. 2 into root 2 into l by 4. By 4. Now with that, 2 ones are 2 twos are. Again 2 can be mentioned as root 2 into root 2. 1 root 2 get cancelled. Then we'll get it as L by root 2. We'll get it as L by root 2. That is the O dash. Understood? This is very, very important. The distance between the two center of masses we need to know. That is very, very important. So here small d is nothing but in the total diagonal 1/4 part. And that's why O dash is equal to diagonal. Already we mentioned here root 2 into 2l. Then with that I considered that O dash is equal to L by root 2. Okay, and now here I need to calculate the shift in the center of mass, delta x cm. Already you know the formula. What's the formula? And that is nothing but minus m removed into distance between the two center of masses by m initial minus m removed. Here minus indicates that, this minus indicates that the shift in the center of mass is in backward direction. So that is equal to, just forget about the minus. This minus I am forgetting about that. M removed. M removed means what's the value? L square. L square. And then what is the D? D is nothing but what's the value? L by root 2 by M initial. What is the M initial? 4L square minus M removed. What's the value? L square. Now delta x cm is equal to delta x cm is equal to L square into L cube by root 2 whole divided by 4L square minus L square, 3L square. Now L square and 2 L's get cancelled. In the numerator only you have L. In the denominator you have 3 as well as root 2. 3 into root 2, that is 3 root 2. This is the shift in the center of mass. Delta X Cm is equal to L by 3 root 2. Okay. Now I'm taking another problem. This is the problem. And in this problem, at first we try to understand the problem. From a uniform square plate of side 2L, a circular plate is removed. A circular plate, nothing but a circular shift in the center of mass we need to calculate. Circular shift means from the square plate, one circle is removed. Sir, in the square, where is the circle? That is the question, right? So now I need to consider like this. And this is the square. This is the square. What is the side of the square given in the problem? What's the value? 2L. Concentrate properly. 2L. Circular shift. In the last problem, we have calculated. In the last problem, we have calculated the one. Okay. And this is the question. From a uniform circular plate of side 2L, a circular shift in center of mass is. Here I consider one square of side 2L. I need to calculate the circular shift. For that purpose, here I am removing a circle. I am removing a circle like this. If you remove a circle from the square, whatever the circular part is there, if I remove from that circle, then what happens here? That can be the center of mass can be shifted backwards. It coming back along this direction, along the diagonal, it moving backwards. So initially the center of mass is O. Just now previously we calculated that the removed part center of mass is here, exactly at the center of the circle, and this is O dash. O dash is equal to small d. Previously we calculated that what's the value of O dash. O dash is nothing but what? Diagonal by 4, same as it is, diagonal by 4. And again here diagonal by 4 means the side also same as the previous problem. Then d is equal to what's the diagonal here? What's the diagonal? Root 2 into 2L by 4. And then if you solve this, then you will get that L by root 2. This is the distance between the two center of masses. In the problem, I am mentioning that like this. This is the distance between the two center of masses, O and O dash, L by root 2. Okay, now there is no confusion. Very simple like these problems. If you know the mechanism, then it's very easy. Concentrate properly. Now, I need to calculate mass, initial mass, M initial proportional to area of the square, nothing but side square, 2L whole square, 4L square you know well. And then M removed part area. Previously, removed part is square. Now in this problem, the removed part is circle. What is the area of the circle? Pi r square. What is the area of the circle? Pi r square. So now here we need to consider that pi proportional to pi r square. Pi r square. Then where r is the radius of the circle. What is the radius of the circle? Just observe here carefully. Just observe. Just observe carefully. This total 2L. I required only this. This is the radius. Radius of the circle. That is the radius of the circle. Concentrate. Concentrate. In the diagram, I mentioned a double arrow line. That line represents the radius. It means what? Total side is 2L. In that exactly half is L. In that again half. From here to here L. This is L and this is L. L plus L, total 2L. In the L, in the side of L, again I required half of the part. That is L by 2. So here R is nothing but radius 2L by 2. Now M removed proportional to pi r square L by 2 whole square. Now M removed proportional to pi L square by 4. Pi L square by 4. Now I know the value of M initial. I know the value of removed mass. I know the value of distance between the two center of masses. Now I am taking the shift in the center of mass, delta x cm. Shift in the center of mass, delta x cm is equal to, what's the formula? M removed into distance between the two center of masses by M initial minus M removed. So here we need to keep minus. That gives that shift in the center of mass is in backward direction. That we can consider. Okay, now delta x cm is equal to M removed pi L square by 4. This is the value of M removed pi L square by 4 into D, distance between the two center of masses. What's the value? L by root 2 whole divided by M initial. What's the value? 4L square minus M removed. What's the value? Pi L square by 4. Next, delta x cm is equal to. So from the denominator, take the L square as common, and numerator L square, denominator L square get cancelled. And then in the numerator we have only pi L by 4 root 2 divided by, here LCM is 4 4s are 16 minus pi by 4 and 4 get cancelled. Now the shift in the center of mass is delta x cm is equal to observe pi L by 16 minus pi and root 2 left here, root 2. This is the shift in the center of mass in this case. Okay, now the next one I am taking here. This is motion of center of mass under external forces. Motion of center of mass under external forces. Okay, now at first for this I need to take one introduction. After that we will take one problem for this. Okay, now what is the introduction of this? Very simple. There is no complication if you concentrate properly. Otherwise, every concept in physics seems to be very difficult, right? If you concentrate, even when big rock also seems to be a small stone. Now, here I'm taking one coordinate system like this, x-axis, and this is y-axis. Now here, from the origin, one bomb is projected. One bomb is projected by making some angle theta. Whenever I said by making some angle theta with horizontal, then it follows a path. That path is like this, parabolic path. Parabolic path. In this, observe carefully. Actually, this is the concept. At the highest point, what happens? That bomb explodes into two pieces. That bomb explodes into two pieces. One piece dropped, nothing but two pieces. Here we consider like this. One piece is dropped from there itself. The another piece followed the path. The another piece followed the path. So if another piece followed the path is nothing but what's the one here? Actually, that can be followed. The another piece can be followed like this. One piece can be naming as M1. The another piece having the name is M2. M1 falls from there itself onto the ground. The another piece, nothing but M2, followed this dotted line. Followed this dotted line. Okay, now what is this continuous line? What is this continuous line? So here, what is this line? What is this one? This one is nothing but this is the path of the center of mass. If the bomb explodes into number of pieces, if the bomb explodes into number of pieces, try to understand this term, very, very important for the conceptual as well as assertion and reasoning, very, very important. If the bomb explodes into two pieces or number of pieces, all the pieces are moving in different directions, but at the center of mass, whatever the particle is present, it follows the actual path like earlier. It means before break into number of pieces, whatever the path is followed by the bomb, in the same path, after break into number of pieces, at the center of mass, whatever the particle is present, that should follow. Okay, so this is the path of the particle of center of mass. Okay, so now this is the simple topic. Once again, I'm briefing this topic. Very simple. A bomb is moving in the parabolic path. At the highest point, it explodes into two pieces. The mass of one piece is m1. The mass of another piece is m2. m1 falls there itself onto the ground, and m2 followed the another path which we considered in the dotted line in the diagram. Then one curved path here we mentioned, continuous line. This is the continuous line. We consider the curved path. That is the path of the particle at the center of mass. At the center of mass, whatever the particle is present, that can be followed this continuous line. Okay, so this is the topic. Now, based on this topic, here we are taking one problem. This is the problem. A bomb is thrown at a speed of 20 meters per second at an angle 45 degrees. At the highest point, it explodes into two equal mass. The one part coming to rest, find the distance from origin to the point where the other part strikes the ground. Find the distance from origin to the point where the other part strikes the ground. That we need to calculate. Okay, now I'm solving this problem. Just concentrate. Just concentrate. Very simple. No complication. Origin. Okay, at the highest point. Now the bomb is moving like this. Moving. And this is the highest point. At the highest point, this explodes into two parts. Two parts. Actually, this has to follow like this. If the bomb is in the correct path, nothing but before explosion, if there is no explosion related to the bomb, then the bomb follows this path and falls at this point. Now, in this case, the bomb explodes into two parts. One part falls down, equal masses. This is M and this also M. So one piece reached to the ground, the another piece followed, like this and falls at this point. In the concept, I said to you, what is this point? This is the point of the particle. That particle exactly situates at the center of mass. The center of mass, at the center of mass, whatever the particle is present, that follows this point. Now, as you know, the topic of the path of projectile, oblique projection, and this gives the range of the projectile. So this is the x-axis. It means what? This is the position of the center of mass. Why? Because at the center of mass, whatever the particle is present, that particle situates here. So this is nothing but xcm. This is nothing but xcm. And this is exactly half. So it means r by 2. In the total range, exactly the first particle falls onto the ground at r by 2 distance. This is r by 2. Now, we need to calculate the other part of the distance. The distance of the other part, we are mentioning it as x. We are mentioning it as x. We need to calculate this value only. That is the question. Find the distance from the origin. Find the distance from the origin to the point where the other part strikes the ground. Where the other part strikes the ground. Okay, so where the other part, that other part is striking the ground at a distance x from the origin, that we need to calculate. So for that purpose, at first here I am calculating the range of the projectile. R is equal to, what's the formula? U square sine 2 theta by g. U is nothing but 20 square sine 2 into theta is nothing but 45 by g is nothing but 10, and thereby if you solve this, then that value is nothing but here 400 by 10. Sine 90 is nothing but 1. 400 by 10, that is equal to 40 meters. This is the range where the center of mass is present, 40 meters. Okay, now here I am taking the xcm. Xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. Where is the xcm? Xcm exactly at the range. Exactly at the range. So here I am placing that m1, first particle, where it is r by 2 distance. Mass is m, x1 is r by 2 plus m2. What is the mass of the second particle? Equal mass, no? M. What is the second particle distance from the origin? That we need to calculate as x by total mass 2m. Then what about the xcm? Xcm is nothing but exactly range of the particle that we calculate as 40. So 40 is equal to, take out the m as common and get cancelled, r by 2 plus x by 2. Take the cross multiplication, 42s are 80 is equal to r by 2 plus x. What is the r? 40. 40 by 2, 20. Now x is equal to the 20, take this side, 80 minus 20, and that is equal to, what's the value? 60 meters. That is the position of other part from the origin. Okay, and now, so like this, we can solve the problems in center of mass. So I have taken till now very important problems. If you understood these problems, then it's very easy to understand remaining numericals in center of mass. Okay, now I'm taking one part in rotatory motion. In rotatory motion, I'm taking conceptual part. Listen. So rotatory motion. If your body is in rotatory motion, that body must and should satisfies some equations of motion. Some equations of motion. Already, you know, in translatory motion, some of the equations of motion already you know that one is v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as. And these are the equations of motion of a body which that body moves in the translatory motion. Translatory motion. Okay, now we are in the topic of rotatory motion. In the rotatory motion, we need to know some of the physical quantities. Some of the physical quantities. So what are those physical quantities? Angular displacement. Angular displacement. That we are mentioning with theta. We can measure in radians. We can measure in radians, angular displacement. Then in the translatory motion, we have velocity. Velocity, we also call it as linear velocity also. Linear velocity also. But now we are in the lesson rotatory motion. So that linear velocity I am replacing with angular velocity. That we are mentioning with omega. Omega. Unit is radian per second. Unit is radian per second. Then acceleration in the translatory motion. We are in the rotatory motion now. So angular acceleration. We are mentioning it as alpha. We are mentioning it as alpha. The unit is radian per second square. Radian per second square. Angular displacement, radian. Angular velocity, omega. Unit is radian per second. Angular acceleration is alpha. The unit is radian per second square. Fine. So here, how come we consider the formulae which are related to rotatory motion as well as the translatory motion? Now we'll see. Okay. Observe. So some here I am mentioning that linear motion or translatory motion. Linear motion, one column, and then rotatory motion, another column. Rotatory motion or rotational motion. Anyway, both are same. Rotatory motion or rotational. So linear motion at first here I need to consider first one v is equal to u plus at. You know this formula very well, I hope. V is the final velocity, u is the initial velocity, a is the acceleration, t is the time. V is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. Now, here I am taking that angular velocity omega. V, final velocity, final linear velocity. So angular velocity I'm taking here V the omega 2. Omega 2. V is the final. Omega 2 is the final. Is equal to U. Initial. So initial means here I am taking omega 1. Initial velocity. Initial velocity V and U replace with omega 1 and omega 2. Plus A acceleration. And here angular acceleration. A replace with alpha into T. Omega 2 is equal to omega 1 plus alpha into T. Okay, next one. S is equal to ut plus half of a t square. Here omega 1 is the initial angular velocity. T remains the same as it is, plus half a acceleration. Here angular acceleration alpha t square. Next, another formula, you know well, v square minus u square is equal to 2a, yes, v square minus u 2a, yes. So v square omega square minus u square omega 1 square is equal to 2. A means acceleration. A replaced with alpha. S is the displacement. Replaced with angular displacement, and that is theta. Now, so again, here we used to take another formula, Sn, the distance traveled by the body in nth second, u plus a into n minus half. Sn is equal to u plus a into n minus half. Sn theta n is equal to u omega 1 a alpha into n minus half. Okay, like this. And then average, we need to calculate the distance. S is equal to, whereas in this average velocity, distance is equal to average speed into time. Distance is equal to average speed into time. Distance means here we used to consider that S replaced with angular displacement theta, U replaced with omega 1, V replaced with omega 2 by 2. Everywhere, anywhere, time remains same, that is T only. Theta is equal to omega 1 plus omega 2 by 2 into T. Theta is equal to omega 1 plus omega 2 by 2 into T. Okay. So these are the formulae in the case of rotational. Now, just take a look on this. And then in this, we need to learn some of the differentiation factors also. Okay. And those one I'm mentioning here. As you know that velocity, linear velocity, V is equal to, what's the formula? Rate of change in displacement is called velocity, ds by dt. And whereas here, V replace with omega, S replace with theta by dt. Omega is equal to d theta by dt. This is a linear velocity and this is angular velocity. Omega is equal to d theta by dt. Okay, and now in the same way, acceleration. Acceleration is equal to, what's the formula? Rate of change in velocity is called acceleration. Rate of change in velocity is called acceleration. A is equal to, what's the formula? Acceleration replaced with angular acceleration alpha is equal to V replaced with omega by dt. Alpha is equal to d omega by dt. Okay, now with this again we are taking one more. A is equal to, here we are taking the concept it as V dV by dx or V dV by ds. Here I consider yes, no, that's why again I am taking yes. This is a one form of acceleration, this is one form of acceleration, linear acceleration. Okay, so alpha is equal to v replace with omega, d omega by d. Yes, yes means theta here, and displacement d omega by d theta, d omega by d theta. These we know, we need to know for doing further numericals in rotational motion up to some extent, okay, just focus on this. Okay, now I'm solving the problem. This is the problem. Of pi radian per second square about a fixed axis perpendicular to its plane and through its center. So here some questions are there, 3 questions. Find the angular velocity after 4 seconds, find the angular displacement after 4 seconds, find the number of turns accomplished by the disk in 4 seconds. Okay, so like this we have 3 different problems. These 3 different problems we are doing with 3 different formulae. Okay, so first one, in the problem what they mentioned, what they given here in the problem, what they given, constant acceleration, constant angular acceleration, alpha value they given in the problem. Alpha is equal to, what's the value, pi radian per second square, pi radian per second square. Okay, now find the angular velocity of disk after 4 seconds. Disk starts rotating with constant angular acceleration. It means initially the disk initial angular velocity is 0. We need to consider initial angular velocity is 0, omega 1 0. We need to calculate omega 2 after 4 seconds. What is the final angular velocity after 4 seconds? Now which formula I need to consider? V is equal to u plus at. Omega 2 is equal to omega 1 plus alpha t. Alpha t. Omega 2 is equal to omega 1 0 plus alpha pi. Time is nothing but 4 seconds into 4. Then omega 2 is equal to, what's the value? 4 pi radian per second. This is the first one. The angular velocity after 4 seconds, what's the value? 4 pi radian per second. Okay, next we need to calculate the angular displacement after 4 seconds. Okay, so angular displacement here I need to calculate. What formula I need to select? S is equal to ut plus half at square. That is the displacement. Here angular displacement theta is equal to omega 1 into t plus half alpha t square. Theta is equal to, that we need to calculate. Omega 1, what's the initial value? 0 into t plus half, what is the alpha given in the problem? Pi t square 4 square. Then theta 0 into anything equal to 0, 1 by 2 into pi. 4 square is nothing but 16. 2 1s are 2 8s are, theta is equal to 8 pi radian. 8 pi radian. Okay. And then what's the next one? Number of turns. Find the number of turns accomplished by the disk in 4 seconds. In 4 seconds. Okay, that we need to calculate. So here for that purpose, just now we considered that what is the angular displacement? 8 pi radian, that is theta. So theta is equal to 2 pi n. This is the formula. Theta is equal to, in the form of number of rotations, 2 pi n. Now what's the theta value? 8 pi is equal to 2 pi into n. 2 pi 1s are, 2 pi 4s are, nothing but n is equal to, what's the value? 4 rotations. 4 rotations. Like this we need to solve the problem. Okay, fine. Next problem. So for doing this problem, we need to know some formulae. Okay. And differentiation formulae we need to know for doing this problem. Okay. D by dt of constant 0, d by dt of t power n is equal to n into t power n minus 1. For doing this problem, we required this formula. Differentiation of constant is equal to 0, and d by dt of t power n is equal to n into t power n minus 1. D by dt of x t power n is equal to, x is a constant, take out from the variables x, separate this, d by dt of t power n again, n into t power n minus 1. These three formulae very important for doing the numericals in physics related to the differentiation problems. Okay, now come to the integration part. Integral 1 into dt t plus c, integral t power n into dt t power n plus 1 by n plus 1. So these formulae we required for doing this problem. Okay, now I'm solving the problem. Now I'm solving the problem. A wheel rotates with an angular acceleration given by alpha is equal to 4at cube. Given that what's the equation? Alpha is equal to 4a t cube minus 3b t square. 4a t cube minus 3b t square. Okay, what we need to calculate? In the problem given that initial angular speed is omega naught, then what is the angular speed after t time antunaru? So now here at first we need to consider that alpha is equal to, what's the formula? d omega by dt, and take the cross multiplication. D omega is equal to alpha into dt. D omega is equal to what? Alpha into dt. Okay, now integrate both sides. Integral d omega is equal to integral alpha into dt. This is the formula for this. Okay, so here we need to take this formula. Integral dw is equal to d omega is equal to integral alpha into dt. Integral d omega from where to where? From initial to final, omega 1 to omega 2. Integral d omega, nothing but what's the formula? Omega, lower limit is omega 1, upper limit is omega 2, is equal to integral alpha given in the problem 4a t cube minus 3b t square into dt. Okay, now first substitute upper limit in the place of omega 2. After substituting the upper limit, need to take minus and take the lower limit omega 1 is equal to, split the terms, 4a t cube into dt minus 3b t square into dt. Split the terms by the integration. Now, omega 2 minus omega 1 is equal to, take the 4a. A is also constant, 4 also constant. Take out from the integral, 4a integral t cube into dt minus 3 constant and b also constant. Take out the integration, 3b integral t square into dt. Now, omega 2 minus omega 1, 4a. Previously, I said to you that one formula, integral t power n dt is equal to t power n plus 1 by n plus 1. Here n is nothing but 3. 3 plus 1, 4 by 4 minus 3b. Here n is 2. T power 2 plus 1, 3 by 2 plus 1, 3. 3b by 3b into t cube by 3. N plus 1, t power n plus 1 by n plus 1. 4, 4 cancel, 3, 3 cancel. Omega 2 minus omega 1 is equal to a t power 4 minus b t cube. Omega 2 they asked to calculate. Omega 2 is equal to minus omega 1, send that side, plus omega 1. So omega 1 plus a t power 4 minus b t power 3. And this is the final angular velocity, omega 2. Okay, and this is one question in that. Again, we are solving another question. Angular displacement. We need to calculate the angular displacement. So angular displacement means, how come we consider that? Omega is equal to d theta by dt. Omega is equal to d theta by dt. Then d theta is equal to omega into dt. Now take the integration. Integral d theta is equal to integral omega into dt. Integral d theta, that only we need to calculate. Angular displacement. Integral omega. In the last problem, we got the value as omega is equal to, what's the value? What's the value in the last problem? And that is omega 1 plus a t power 4, omega 1 plus a t power 4 minus b t power 3. Omega 1 plus a t power 4 minus b t power 3 into dt. Then theta is equal to, split the terms, omega 1 into dt plus integral a t power 4 into dt, split the term again, minus integral b t power 3 into dt, Now theta is equal to omega 1, take out integral dt plus a, take out from that, integral t power 4 into dt. Why? Because all are constants, minus b integral t power 3 into dt. Now theta is equal to omega 1, integral dt is t plus a integral t power n dt, t power n plus 1 by n plus 1, t power 4 plus 1, 5, t power 5 by 5 minus b t power 3, t power n plus 1 by n plus 1, t power 4 by 4. And this is the angular displacement.